So lysosomes are organelles that contain enzymes that help to dismantle and recycle food particles, captured bacteria, worn-out organelles, and other debris. So all of these things, the food particles, the bacteria, etc., are all made of biomacromolecules. And as you know, these are the building blocks for different structures and other macromolecules if you can break them down and build them up again. And that's exactly what lysosomes do. They're able to recycle these macromolecules. They're named lysosomes because the enzymes that are contained in lysosomes lyse or cut up their substances. So the rough ER actually manufactures the enzymes that are inside of lysosomes. The Golgi apparatus then detects these enzymes by recognizing a sugar that's attached to them and then packages them into vesicles that eventually become lysosomes. And the lysosomes in turn fuse with transport vesicles carrying debris from outside or within the cell. And the enzymes inside the lysosomes break down these large organic molecules into small subunits through the process of hydrolysis. And this releases them into the cytoplasm for use by the cell, so it can build other structures. So let's have a look at this throughout this diagram. We'll look at this process. So first of all, we know that the enzymes for lysosomes are made in the rough ER. And those enzymes then move into the Golgi apparatus, where they're packaged into vesicles that eventually become lysosomes. So here are two lysosomes that have pinched off in their own little membrane from the end of a Golgi apparatus. And that's the third step. Any debris that might be floating around inside of the cell that the cell needs to digest is enveloped in a vesicle. So here is some damaged mitochondrion, which is no longer working and it needs to be digested, and the molecules from that need to be reused inside the cell. So the mitochondrion gets enveloped by a vesicle, which will eventually fuse with a lysosome, and that lysosome then releases the lysing enzymes into that vesicle and digests the mitochondrion through the process of hydrolysis. Then that product or the products of that digestion are available for use throughout the cell, so the cell can use that to build other structures. Now lysosomes can also break down debris that comes from outside of the cell. So over here we have some debris that is entering the cell, and again lysosomes pinching off the Golgi apparatus can fuse with the vesicles carrying that debris and eventually digest that debris so that the molecules can be used in the cell. This micrograph shows an image of fragments of mitochondrion and of peroxisomes actually inside of lysosomes, and there are digestive enzymes at work inside of those lysosomes breaking down those two organelles so that those macromolecules can be reused by the cell. Some cells have more lysosomes than others. White blood cells, for example, have many lysosomes because these cells engulf and dispose of debris and other bacteria as part of your immune system. Liver cells also require many lysosomes to process cholesterol. So what keeps a lysosome from digesting the entire cell? The lysosome's membrane maintains the pH of the organelle's interior at about 4.8, much more acidic than the neutral pH of the rest of the cytoplasm. So if one lysosome would burst, the enzymes are no longer at their optimum pH, so they can't digest the rest of the cell. Nevertheless, a cell that is injured by extreme cold, heat, or another physical stress can actually initiate its own death by bursting all of its lysosomes at once.